Welcome to the docking tutorial section. In this section, we are going to see about docking. Docking is a process which predicts the preferred orientation of one molecule to a second when bound to each other to form a stable complex. And for docking processes, generally, they are based upon either shape complementarity or simulation process. So mainly two types of docking are carried out. One is known as ligand docking, the other one is known as the protein-protein docking. The first one is known as protein ligand, the second one is going to be protein-protein docking. There are so many softwares and online servers are available for this docking process. For example, if you want to carry out protein ligand docking, we have softwares like Hex, Argus Lab, Autodock, and Dock. And if you want to carry out protein ligand docking in online tool, there is a PatchDock and Hex are the good online servers are available for protein ligand docking. Similarly, to carry out or to check the protein-protein docking for the softwares, we have a software known as Dock is used for protein-protein docking, and to some extent X is also used, and then MolSoft is another tool which is used for protein docking softwares. If you go to online, we have tools like FireDock, Oscar Lab, and then ZDog and ClustPro. These are the online servers which are available to carry out protein docking. And then if you want to carry out a docking as an example, you need a protein molecule, and you need either the other one is going to be a protein or a ligand molecule. So you need two components for docking purposes, and these two molecules should always be required in PDB form. Rare cases you require in either mol or SDF form, but most of the cases we require both the protein and the ligand. For the case of protein ligand binding or docking, you need them in the PDF form. So for this purpose, first you should collect these two molecules in the PDF format to carry out this docking purpose. But in some cases, if you are not having PDF format, you are having the other format, you can easily convert one format into the another format very easily. For example, the drugs are available in the only in SDF formats. Some chemicals are available in only mol format. So you can change this mol or SDF format into PDB format by using certain tools like Corina is one of the tools is used, eBabel is another tool which is used, and Smile Translator is another tool used for convert this mol, SDF and Smile formats into a structure format. With our class, we have Marvin Sketch or Marvin View tools. By using that, you can convert one format of a structure into another format. For a protein molecules, if you have a PDB structure in protein database, you can easily download from that database. If you are not having a proper PDB structure for a protein sequence, you can predict the tertiary structure of the protein by using either homology prediction servers like CPH model or Swiss model. You can use it, or you can go for the other threading method of softwares like or online servers like 3D PSSM or PyD, or you can go for an ab initio prediction tool ITAS. Okay, so by using any one of these prediction servers, you can predict the structure of protein, or simply you can download the structure if it is available on the protein database. So if you have the two molecules, you can easily carry out this docking. So now for our tutorial, we are going to use PatchDock server to predict the docking. Okay, then one more thing is that if you want to carry out online server, you need an email ID because they will send their output mostly in email only. So you need email for getting the results from the docking server. Now we will see that. But in the case of tutorial purpose, we explain how to carry out the docking in the case of X software also. So both the things we are going to discuss in this particular class. So first we will see by using the online server. So for this purpose, you select the PDB file of drugs. You can see here, if you want to carry out protein ligand docking for a particular drug, you first get the PDB structure of the drug. For example, here we have a ritonavir, and for this ritonavir drug, we have structures in mol format, SDF format, and PDB format. since for docking we require PDB format, you just click the PDB and it is available in the PDB file is there, and as usual you save this PDB file, and then it will be saved with this text format. You just remove the text and you can save the file by giving double quotes. It will be saved as a PDB format. So it is already saved, so you best use it. For difference you add a and save it in this folder, and you can now the file is downloading. You can see in this folder. So this is what the drug we have just downloaded it. That is 503A is the file is downloaded just now. So to check whether it is in a good format, you can see the structure of this molecule in Marvin space, or you can see it in either Marvin view, Marvin sketch, Marvin space, but Marvin space is a better tool to see the three-dimensional structure of the molecule. So we can see the structure where it is available in a good status. So this is what the PDB structure of the drug. So after downloading this drug, now we have to download the PDB structure of a protein, or you can predict the PDB structure of the protein from the CPA server. So we are interested to get the target. So we are going to use the proteases. Okay, so it is actually act as a target for this particular drug. So you go to this target point and you have the thing is protease as a target for this particular drug. When you go to this protease link and you have a Unicron link in the protease target point, and then you click the protease link, and now it goes to the Unicron database, and you go to the sequence part. Even you will go to the structure part of the Unicron file. If it is structure is available, you can see here also. You can click the structure region. If it is available, you will get the PDB link here itself, so you can directly download the structure of the PDB. If there is no structure is available, it's better you will go to the sequence part of this file, and from this sequence part you get a FASTA format of this sequence, and you just go to the Google for the purpose of precise structure prediction, because structures are not available in the database. So now we will go to the CPH server, CPH model server. So here you can have a CPH model server. So we go to the CPH model server, then you paste the sequence and you will submit your sequence, and you can get your protein, submitted protein structure as output from this page. Once the protein structure is predicted, you can save the protein structure by using the query.pdb link, and you can save this particular protein in this class folder. So once it is saved, you can see the structure is saved here. You can check whether it is in a good condition. You can use this Marvin space tool. It's very necessary to check whether the both molecules are in good state. Otherwise, you may not get good dark structure output. So since it does not show it properly in the case of Marvin space, you can check some other program to see the tertiary structure whether it is in good condition or not. In the meantime, we will go to the server for docking. That is, we are preferred to go to the PatchDock server. It's taking a little time. So it is predicted. Okay, now this is the predicted structure of this proteases. So it seems that the predicted structure of the protease is very good for the docking purpose. Okay, so now we will close the software and then we go to the PatchDock server for docking purpose. See here a PatchDock server. And if you go to this PatchDock server, there is two options there. One is that it needs a receptor, so you can load a receptor into this first part, and then you have to load the drugs in the second part, and then you should give your email ID in this link, and then you select protein ligand docking options, and then you just submit the PatchDock server for the prediction of the structure. To see the output, you should check your mail. So go to your mail ID. So in this mail ID, you will get the results of PatchDock. Results will be, it is a simple server which gives, go to your mail ID, and then you check your mail, and you will get results like this. So the PatchDock will give results like this. You can see if you click the results, they will give a list of 10 or 20 dock structures are available with the PatchDock results, and this always the hits are listed on the basis of the score. The topmost result will have highest score. So to get a single file, you will save it by using this right click option in the class folder, and if you want to download all the 10-20 files, you will use this download best solution option to download all the files, and then to save this table and all, just to save this page as PatchDock result, so the whole page is actually saved. So this is how you can run PatchDock server and you get the output. You can get the output within 10 minutes. So after submitting your sequence, within 10 minutes the PatchDock server actually provides your results, and these scores are used to compare different dock tools. So in this tutorial I explained talking of one drug and one protein molecule. Like this you can carry out for different drugs. Even after virtual screening we may get several hits. You can also dock those hits into this particular proteins. When you are using the hits molecules, the hits are usually available in SDF format. You should convert that SDF format into PDF format, and then you have to use this PatchDock server to carry out the docking purpose. How we will convert that SDF format into PDF format is very easy. So say for example, this is the hits which are obtained after the quasar virtual screening method. You just open that hits SDF file by using this Marvin sketch. So when you open it, the Marvin sketch will ask which molecule I want to open. You can open the files one by one, that is number wise. Say if the molecules contains around 58 molecules, it will ask which molecule I want to load it. So you just load one molecule. It is numbered as a hit 1. So it is actually open in SDF format. Now you save this file as a PDF format. Okay. So this is how you can simply convert the SDF file format into a PDF format. So see, now you can number it as it's one new. Okay. In the bin folder it is already there, but we have to change this into a class folder, which is also available in the 2015 folder. It is actually available. We save this. In this folder we save as it's one new. So now I have converted SDF file format hits into a PDF format. See, this is the hits what we are going to see simply as a PDB file by using DSV1Lite. So this is how you can convert the SDF files into PDB file of hits, and then after converting the hits file SDF format into PDB format, you can use the hits for docking purpose. So this is how we can carry out docking of both hits and the protein as well as the drugs. So you can carry out docking of both drugs and the hits and proteins. And in the tutorial, that is in the text part, we will explain how to dock it with the Hex software. So it's also very much easy in the software. If you install the Hex software, after installation of the Hex software, you just to open by using an option of open receptor option, you load the ligand file and receptor file, and then using the graphics option, you go to the convert receptor shape into harmonic surface, and then you have to change the ligand to polywire, and then you have to use open controls and orientation control option, then move the ligand and receptor close to each other, and then you should click the fit ligand option. After fitting these ligands, you just open the control option. There is another option known as docking control option, and then in that docking control option you just select the correlation type shape electronic option, then you also select post processing type and initiation option, then you click the activate docking option. So once activate docking option is enabled, the docking started. Once docking is completed, you just save file save docking option might be used for saving energy details, and then file save both option is used to save the docking. So this is how you can easily use the Hex software to do the docking. So we already see by using an online PatchDock tool, and this is also the text which explains how you can use Hex software for docking in an offline manner. Okay, so this ends the docking tutorial section. Thank you.